Cool. So, hello. Oh my goodness, it's so full. Hello. It's really very nice everybody joined. We have one question before I start, which is there's going to be some photographs of this room. So does anybody mind that we post that on social media and stuff like that? No? She has a blurring filter thing and it will. Okay, great. So, I'm tangled. That's not going to work well. That's going to end up in misery. Everybody, welcome. My name is Attila Houtkooper, as has been butchered by Adele. But, we'll train her and she'll get that thing. Good. I'm going to talk a little bit about the lessons from the backend. We've been doing a project here for the past year. And that's actually live, so we're actually using this stuff. I'm not going to talk about a lot of the fancy stuff, or at least I think it's not the fancy stuff, because I'm going to talk about what we actually use and what we actually enjoy from the language itself. As has been said, I'm CTO of machine learning, although this has nothing to do with that, but I just really like the language and I wanted to share this with you. So like I said, features we use. So a little bit about the basics. Maybe a good show of hands would be how many are using Kotlin live in an actual application. Okay, those are many people. So I will do this slide by slide. If people are not interested in seeing examples of basic stuff, then we'll move on. Otherwise, I have examples of basic stuff. Good. So I'll talk a little bit about integration with frameworks, Spring, Jackson, GOTO, and then discuss some of the things that we sort of struggled with, or not really struggled, but sort of had a first struggle with and then won. Before I say PHP, so I have a background in PHP. No, I wanted to show you this. This is the way I got introduced into Kotlin. Indeed, somebody got that right. That's what I wanted to say. By applying this to an internal application that I made for myself, and that was initially built in PHP. Okay, so I chose PHP at that point because that's what I learned to do when I was 15 or something like that. So fine, it was very fast to make software. It's very simple, it's very nice to do these kinds of things. But at some point you hit the wall, and you gladly change in that speed and simplicity for scale and the assurance of a strongly typed thing, and that really makes you happy at that point because you just want the thing to work. But then, in I think October, November 2016, I ran into this Kotlin thing, and I decided to do to check it out, basically. And I got simplicity back, less code. I always love less code, and I got functional stuff back. I worked on 8 months. I worked on Scala. And that had a lot of functional stuff in it, but we couldn't really make that work in a simple way. So it's nice that we could have that mix here. So that was my own introduction, and then when last year in May we started a new project for a major client, I said, why don't we do this in this stuff? Because that's really interesting to do. Let's make this happen. This is going to be hot, and you guys here show that. So major client, they needed to move away, of course, from an existing monolith. Most clients do, and we needed to replace a part of that. So that's what we did. Started in May, like I said. Spring Boot 2 by now. Hibernate, Redis, Gradle. Initially Java, but pretty soon moved to the Kotlin stuff. So, this is going to be lessons from front end. So this is lesson 1. It's cool. So for those that are already using Kotlin, it's pretty obvious. But I guess some of the others want to have some ammunition to tell your team why they should really start to learn this stuff. So I'm here to help you out. So, first of all, why do I want to Kotlin? I don't like to type or read fluff. I want to get to the point. Kotlin allows me to do this. I like to understand the errors that I cause. I make faults. I'm a man. I make faults. Women never make faults. So I like to understand why that is. I love up-to-date documentation. Everybody does. I'm really into predictable and relevant APIs, and people pick this up very easily. So that's, I think, pretty good. Then there's, of course, a bunch of other reasons. So I put them all in a word cloud with animation. Awesome. Anyway, so lots of reasons. So now let's get to the code. And this may be the basic stuff, so I'm going to just browse and see what I need to get into deeper, because I also talk to people that haven't used Kotlin as much, so yeah, I want to strike a nice balance in it. So I'm going to talk about these subjects, very basic stuff first, implicit types, no more specifying the type when you declare something. Null-safety is a feature that we have a lot of fun with. The methods that we can do on lists, so the functional programming part of that, and something about extensions and type aliases. That's basically what this talk is about in terms of the basic Kotlin stuff. So first of all, implicit types, very simple. We get to define a function, looks like this. It's a function that turns a string into another string, so we can call that with my ever creative blah example string, which you will see a lot more of, I think. And then if I juxtapose it to Java, then we get a little bit longer piece of code, but we still sort of like this new syntax that Java introduced. Although I don't like apply. I don't know why it has to say apply here. I never asked for that. I don't care about apply. But okay, that's fine. No good reason yet. So now I want to do a function that has a little bit more arguments, because I write software and that has functions with multiple arguments. I stutter as well, so sometimes it's really, really exciting what's going to happen next. Again, I did it. But sadly that sort of looks nice in Kotlin, and then in Java it's bit of sad story, but there's two ways to be sad. There's one where you sort of nest these functions, so then it looks like you're doing something that's nice. So that's cool. And then you get to apply some more, so that's nice. Of course, this isn't going to be a Java bashing evening, but I cannot resist. The other thing is where you have to determine a separate interface that sort of gives you what you want, and then you can use that, and that says, sing. That sort of gets closer to where I want to be, although I don't want to be there. And I still get the one apply. Does anybody want to see an example of this stuff? Yeah, okay, good. Let's look at that. Is this visible for everyone? Yeah? Oh yeah, so it's a very stupid and simple example, but we can run it at least. And then it's too big for the thing. But, so, okay, that's interesting. So it generates a function, or it generates a string. Oh yeah, right, I call this string. Oh, that's stupid. That should have been blah, right? I don't like that. Make that obvious. So there you go. So it's very, very basic stuff. We can define a function without it being the member of a class or anything, just an inline thing, and then just use that. So far, so simple, I would say. If there's questions, and I'm looking at my screen a lot, please just shout out and say, hey, but wait, this sort of thing. And then, of course, the Java equivalent is like I showed on the slide. It's a little bit more involved. Okay, good. Let's look at something else. Null-safety. So one of the sort of billion-dollar mistakes is that, as it has been dubbed, is the introduction of null, because of all the faults that are made, and then we still try to deal with this stuff. And Kotlin does this, I think, in a really nice way, in principle. Basically, you say in a very short way, you say, well, this could be a string. It could also not be a string. In this case, I'm being really explicit that it's not a string, but that could have been a var, or it could have been something that comes out of a function, and that could have been not that obvious. And then we have a way to say, well, let's get a default value. So here what you also see is that an if statement actually returns a value. So you can use that as an inline thing, as a replacement for the ternary operator. So here we say, if it's null, then give me anonymous, otherwise use that string. And what's nice about Kotlin as well is that it does a smart cast, so that maybe string outside of this else block was a string that might be a null, but in here it's going to be an actual string, like a hard string, because we know that we've already checked whether the question mark was there, and if that's not the case, then we know that this is going to be an actual string. So that's really nice. But we could make that a little shorter by using the Elvis operator, which is nice. And then, that becomes a nice small thing. So far, so good. I really like it. Save calls. Here we can sort of chain the calls that we would want to do on an object, in this case, this string, but do it on the precondition that it's not null. So here we would say, get me the length of the string if that string is not null. Okay, fine. Do we want an example of that? Sure, less enthusiasm already. Okay, that's good, that's good. No, that's fine, that's fine. I just spent hours on this stuff, man. No, okay. Is there anything else that I showed on the slide? Yes, a little bit. I didn't show this part, where you say, well, I know that it might be null, but in this case, I'm really certain that it's not going to be null. There's just, I just know that it's not going to be null. Ideally, you wouldn't have much of this in your code, but in the end, you're using frameworks that don't really know about this stuff, and then you'll see that you're using this more than you would like. But it's, yeah, I mean, it works. So yeah, that's it. Good. Next. I'm so happy I brought a clicker because I'm never at the keyboard. Oh yeah, I have a question, I guess. So there's one thing that I like about Java, or for that matter, another language that also does the optional thing, class, and that is that I can map over the optional, which more often than not I would like to do. Because what is mapping over an optional other than just a generalized form of this final case right here? Here I'm saying, if I have a string, I want the length field. Okay, fine. But maybe I would like to do an arbitrary operation once that string is an actual string. And Java gives me that. I can make an optional, which is the sort of the equivalent of that question mark thing. And then I can do map on that stuff. So that means that if this were an actual string, that would become value plus that string. But if it were null, it would, or if it was an empty optional or null in this case, that would just leave that be. So I would like to see this. However, this does not work. Which basically says, well, we have our favorite string here again, and then we say, well, if that is there, do this operation with it, and then the it variable is the default that you use within these operations. However, it's got the crossed fingers there. It's not in. Maybe in a future version of this.
You can do let.
Let.
Yeah, let checks for null, and then if it's not null, you can execute that box with the.
Okay, cool. Thanks. I guess I made a mistake. Okay, cool. I'll look that up. Oh yeah, so then that point doesn't matter. I've got, yeah. Moving on. Okay, functionals. Just for everyone who isn't aware of functional programming, I didn't put a full list of what sort of I mean by that, but these are three of the most common functions. How many of you don't do functional programming? Cool. Well, for you 4 guys, I've made this slide. So it's really, really simple. Map turns a list of something into a list of something else. Flat map turns a list of lists, which more often than you would expect actually happens in code, into a list of something else, which is really nice. And then group by does the group by as you would expect it from SQL or whatever you have, which turns a list into X into a map of something else and pointing to a list of things that have the same Y, so to say. Then that looks like this, which is slightly bigger. Do this. So here what I created is a short transformation function. It takes a list of these report object on the top there. In this case it's only 1, but I was lazy. And it turns that into an object that holds the average of the scores that are included in the original objects and a list of some things called score records. Now, which is really nice is the average is pretty easy to get. You just do you just make sure that the score that you're talking about is not null, and by that time you're certain that that score that used to be a nullable int is an actual int, and then you can have the average of that. Then you group by, which again sort of speaks for itself there, and IntelliJ is nice enough to sort of show us what then that type would be, and we flat map over that stuff, turning a list which is the list of reports into a list of the score records that is what we want, and then by flat map we get one list that holds all of these things all together, and then finally we have a sort of a check that says, well, if that reports thing used to be empty or was actually empty, then never mind, give me nothing, and otherwise give me this new thing. Okay, so that's good. So how does it look in Java? Less great. So you've got sort of the same thing. I have to get it a little bit out of the way, but the average becomes a wonderful dance of stream, weird collector stuff, averaging double, then get the double value for this. It's just a very hard to read bunch of stuff. Then here there's a for each that generates that value and collecting a grouped thing. It's, to me, I know what I like better. And in fact, if I look at the actual code, this actually turns into very hard to read stuff. Just very hard to read. All right. I'm hearing sighs, so I'm moving on. Kotlin has it's fine, it's been a long day. So Kotlin has a bias towards immutability. So that's and that's actually something that I really like in my local variables and in my fields, that I can say, well, this is actually a val in Kotlin terms, and we don't want that to be changed ever again. So that's really nice, and it's a nice shortcut. They have the val for the things that may not change, and the var for the things that may. And for classes, they did a little bit of a different thing. They just said, well, the default thing is final. So when you declare a class, you automatically get a final class. And only when you explicitly say this is open, then you get a class that may be extended, which I will come back to. But it's important to keep this in mind that is there. Another nice feature of Kotlin that we use, not that much, but it's still nice to show, is the extensions feature, where you can say, well, actually put this method on anything that is of a certain type. Much akin to what you can do in JavaScript as well. You can just extend the API of a standard object in this way, or an object that is final or something like that. In this case, I wanted a random range of a certain list, so I could just say, well, add that to the list interface. Another thing which is nice here is that you get this operator that will give you a range with an infix function, which is more to the DSL side of things, but still a nice feature to be aware of as well. Type aliases are really useful for sort of abstracting the complexity in your data structures. I showed that Java function sort of signature. It would be really handy for that stuff. Now we cannot use it in Java, so that doesn't go. But for all the other cases within Kotlin itself, it's really handy to have. Where you can say, well, if I talk about a file table, then actually really what I'm talking about is a mutable map of things, and then I can use that in assignment. Now, it's actually not that useful in this example, but what we found it to be really useful at is when we're passing around these sorts of objects from one method into another, but we're not really doing anything, we're just passing it in to the next. Then it's really handy to have a shortcut so you don't have the signature of this object all over the place. That was a good one. Secondly, you can also do that with functions, where it looks like you have a class now, but it's really just an anonymous function that says I'm turning a string into something else, whatever it may be, and then we can actually use that in that way. It's a really nice one as well. I think type aliases is just that. It does that, so it just yeah. Okay, that's that I think covers it. Okay, good. So that was lesson 1. It's cool. Any questions so far?
Oh yeah, actually I'm quite new to the language, so I was wondering the calibrated syntax that you're using it last time.
Yeah. This one?
Yeah.
You mean this on the bottom line? Yeah. What do you want to know about it, or just observing that it's new?
So this is quite new.
Yeah.
So I have no idea what that does.
Okay. Well, you've got the type of the function, which is this. So this basically says this is the signature of what you're going to create, which says I take a string and I generate a key. Yes, I get it. Yeah, I was going there. I was going from you know. And then the assignment says, well, if I want something of that type, which is in the end what this thing is saying, or at least it's an int, then I want to declare that. So this is the declaration of that function itself. In this case, a curly bracket saying, you know, give me a string and I will give you the length of that string.
But you have only S there, not string? Like S, not S string?
You mean, could you take this out?
Yeah.
I actually, I tried that and I think you can't, although I would expect that you would be able to. But if somebody's smarter than me, please let me know that I'm wrong. But I would expect indeed that you would be able to take this out, because it would be able to find that type by going through the declaration and sort of seeing, that must be a string. But you know, let's try it out. Oh, sorry, you're completely right. Yeah, that's not helping. that maybe
Instead of
mean.
S, right.
Yeah, exactly. Then we can do this. So it becomes even more short. Yeah, you're absolutely right. I think I tried to remove it there or something. I must have been doing the same thing. That's stupid. But yeah, indeed. So then it becomes even more interesting, where it says, okay, we can take this shortcut because if this is if we don't want to give that an explicit name, then we have the default name of it. So we don't have to do any of the I'm getting this and now I want to do that with it. No, it's just going to be I want to do that, and that's basically what that does. Cool stuff. Okay. Right. So that was lesson 1. And any other questions? All super clear. Good. Let's get the one about implementing Kotlin into your projects. There is, I made a funny slide. I remember now. It's with the Simpsons. I haven't decided how to do this yet. So this you're going to be the big experimental group. So this is Homer talking, right? Homer decided to change. You need a little bit of story here. Homer at some point decided to change his name into Max Power. Don't know why he did it. Well, that's a part of the story as well. But let's not go into the details. And now he's telling his kids what it's like to be that man. So he says, kids, there are 3 ways of doing things: the right way, the wrong way, and the max power way. Okay, cool. So Bart asks, isn't that the wrong way? And Homer says, yes, but faster. So let's talk about ways to make this change. Good. So the first one is, woohoo, do everything in Kotlin. Just throw out all that Java stuff. It's all way too much and it's annoying, and just make it all nice and clean stuff. Get it to me. Provided that you're not a super guru at Kotlin yet and you've got some experience in Java, this is probably a pretty bad idea. So I would call that the max power way of doing things. Although this isn't the wrong way faster, I must admit, but still this is pretty shoddy. The other one is to say, well, I really like this Kotlin stuff. It's really short and nice, and I can do DTOs in this very nice data class way, and woo. Let's use it only for the tests. I don't really get that. To me, that's also, hey, that's strange. No, I'm kidding. It's also wrong on my side. But yeah, so that's also the wrong way, because then you're losing out on a lot more fun that you would be having if you were to just use it everywhere. But then using it everywhere shouldn't be done all in one big blow, but doing it step by step. So what did the team say when I said when they sort of joined and they said, well, okay, we apparently are doing this thing. So initially somebody said, who is here right now, maybe they can do it. What is this shit, right? Because I'm used to Java. What is this crap about var and val? Is this JavaScript or something? And then pretty soon they get to the realization that it actually works really, really well. It's a very intuitive way. What I found is that apart from setting up the initial application and doing the sort of the hard parts of making sure the framework works, sort of the little nooks and crannies, apart from that, it went really, really smoothly in terms of a team that wasn't used to the language at all, applying it and using it and finding it really, really nice, to the point where they rejoined another Java thing and actually said, I'd rather do the Kotlin thing instead, but that's life. So that's really, really good. However, you cannot have this unless you do this in a smart way, because you don't want to be the guy that has to tell the client, yeah, we spent a week trying to figure out how this flat map thing works, and yeah, vol and var, there's something wrong there, but I don't know what. Luckily, it never happened because we did it step by step. We did the small stuff first, the simple stuff, and then we incrementally took over the other classes as well. But don't be the team that sort of ends up with some class in Java and some in Kotlin, because then you're losing out on a lot of the simplicity that you would be having. Because then you still have to keep in your mind, oh yeah, this is the way it's going to work in Java, and how does that work with the getters and the setters and all that stuff. Just make sure that you're on a slow and steady road towards just a pure Kotlin application. That was lesson 2. Any questions about this? Yeah?
How do you introduce Kotlin in a team if a team is working on a single project and it's already in Java?
Yeah. So the question is, how do you introduce Kotlin on a team that is already working on a big Java project, basically? I think there's a number of ways to do this. The nice thing about Kotlin is that it's not you don't have to do it all in Kotlin. So one of the sub-steps might be to take, for instance, the tests. Say, well, let me do a test. Let me create this test suite in Kotlin and see how far we can take this. But if you want to get people really riled up and enthusiastic, let them do this on their own. Have a session where you start saying, well, what if we could create this part of the application again, and then using this new thing, and then people actually get their hands on it instead of this guy that does the new and hot stuff. It becomes a thing that's owned by the entire team that says, hey, we really like this stuff. We would like to do this as a team, learn this stuff and move towards this new thing. So I think those are the things that you could look at. Does that sort of answer your question? Okay. Yeah, you?
In your experience, how long does it take for developers new to Kotlin to reach kind of the speed similar to what they had in Java? Or at least to be productive member of the team?
Productive member happens within 2 or 3 days, I would say. The change, and then I'm talking about making changes on existing code. That is due to a very intuitive API. You have a list, you would like to do something with that list, and that API is likely to have been written already, so you don't have to work around the API, you just use the API. So that's very, very nice. To actually master this stuff, there are a few sort of, like I said, nooks and crannies where the mix of Kotlin with an existing framework will give you some sort of headaches where you need some experience and need some time to figure out how you should do this stuff. So yeah, that's the way that I would describe it. I would say with the team members that I've discussed this, and I don't see a very steep learning curve as well, because the interoperability is good. So if somebody says something like, I want this list to be of type array list, for example, which isn't a thing that you would need to do, it would still accept it. It would still say, yeah, sure, fine, I'll make this an array list. But it'll just say, fine, I'll turn it into my own little Kotlin list and move on. So in that respect, it's very forgiving in its syntax as well. And then, of course, you need to have in mind that you sometimes clean it up and say, well, where do we get a lot of Java util things? Let's clean that stuff out because we don't need it. Yeah, so that's the way it would go. Answer your question? Another question there in the back? Yeah? I didn't, and I'm going to talk about it in a minute. We basically used JUnit for it. Any other questions? Okay, cool. So here I get to talk about sort of the problems that can be counted on one hand. In other words, there are very few problems and far and wide in between. So first of all, you get the interoperability with Java. Very simple example of this is, let's look at collections transformer again. This code has more lines than the Kotlin one. While the Kotlin one actually also has the classes of the objects that we're working on, and the Java one actually uses that. So it gets a report, which isn't the Java class. It's just a class that we declared here, and then we get our steady getters and setters and all that stuff, just out of the box, which is again very, very nice if you're gonna be building a part of this in Kotlin. You're going to be able to use that in Java and the other way around as well. Next to that, I already talked about the lists and the array lists and stuff like that. Next to that is when in Java you declare a string that turns into a string that may be null. So here you find some clashes with frameworks where you're saying, well, this is going to be a string, but it turns into a string that may be null, and now you have to deal with all these things that may be null while you're really certain that they're not null. So yeah, let's look at a little bit of Jackson because it underpins the REST stuff that Spring does, and I think it's a nice way to sort of start simply, which the length of this code wouldn't reveal. Okay, so what I did is a very simple mapper, just a few examples of this thing. Let me run it. Yes, so I have a class that I would like to read. I would do it like this, basically passing in a type parameter saying, well, this is supposed to be an instance of this type, and then passing in the JSON string. What I did is I added a couple of interesting things here. First of all, I made a data class, which is a shorthand way to declare a class. You immediately get to, you only have to write this part basically, and that just declares the entire thing from setters to getters to all the things. What is then interesting to see is that we can have an ID that has to be there, but the description need not. So if we skip that, it becomes null. And the same thing goes for the fancy code, and the is awesome actually does need to be there. We also see that we're getting default values, which doesn't make me super happy. For instance, for the false and for the 0, but that's I guess what we get. I'll get back to that in a minute. What is nice here is that we can override the not to my liking feature of removing the is prefix from JSON objects, so we can just pass in an actual thing that actually matches the field that we want to fill, which I like better than the other way. So then we have to do this sort of new to me annotation that allows us to manipulate how the value is set. So that's one. The second thing is very nice. It's a deserializer for, in this case, a sort of a magically formatted string, which I would like to have inside of an object. So here I create a deserializer that goes into the JSON node tree and sort of gets that string if it's there and otherwise doesn't. What is nice here to see, or what is interesting here to see, is that we have here an annotation that indicates that we're doing an overload on a Java class, for the constructor here. What's also nice to see is that we immediately can pass the value that we got here immediately into there. Where in Java you would do a constructor which then calls super, etc., etc. Here we can just have that within that one line saying, well, this maps directly to that argument on the class that we're extending, which I think is a nice feature as well. Any questions about this? None yet? Yeah, I don't have any questions prepared. So either you're going to have to eat the chocolate on your own, or if you have any questions, you can pass it to the room. Okay, sorry. I should have told you. Okay, so that's Jackson.
Sorry, one question. Still.
Yes.
The asterisks in the class.
Yeah.
I never put a spot a rule when I can apply it and when not.
That is a good question, and I don't have an answer for you for that.
Like the wildcard in Java.
Yeah.
It's like the wildcard in Java.
Nothing more. Just like that.
Yeah.
How does it differ from any? Is that a what? Can anybody indicate the difference between that? There's also an any sort of root
Like
object.
any question mark out.
Right. Okay.
So it can be null and it can be also, yeah. You can also only track stuff and not put in.
Okay. Okay. So it's really beyond that. It doesn't need to be anything basically.
It's like Kotlin doesn't allow you to have raw types like without declaring. So if you don't know the type, or it doesn't matter, you just need to define the aspect.
Okay. Okay. Cool. That's cool. I didn't dive into that yet. All right. Next is classes are final by default, which is absolutely great when you're not using any frameworks, because then you get exactly what you want. You want everything to be final and fixed, unless you open it up. You know, this is the new way of doing things, and we really love it. I love it for values, but for classes, it's sort of annoying, because we used to not know, which was nice. Spring would do all kinds of magic stuff, extending our classes and wrapping it around things, and I used to not be really aware of that, and now we have to do that, because it turns out that any of the classes that are annotated with this stuff actually need to be open, because they will be extended at runtime. So we can do this in two ways. We can either go through our code and add the open word for all the things that we know Spring will extend, or we centralize that knowledge and use the Kotlin all open plugin, for which you see the Gradle syntax, and sort of add a list of annotations that for which we want the class and the methods to be fully open, which is nice. I can show the Gradle file, but it doesn't show anything more than this, so I'll forgo that. Any questions or observations about this?
I think there is a dedicated Spring plugin you can have.
Excellent. Then I guess the knowledge is centralized, which would be nice indeed. That's good. So about the interoperability with frameworks, so like I already mentioned, a bunch of these frameworks will say, well, this returns a string in Java, and that then turns into a string which may be null in Kotlin, which is really annoying for stuff for which you just know that it's going to be a string, and if it's not a string, then just give me an error. I don't want to deal with this stuff. Luckily, with Spring Boot 2, they added a lot of annotations saying specifically this is never going to be null. So that's really a useful development for Kotlin, to the point where Spring actively talks about, yeah, this is an optimization for Kotlin, and this is how you use it. So next to the Android stack, now also Spring actively looks at this language as a serious option. Let's look a little bit at the REST controller there. Yeah, time. Cool. That is ridiculous. So what I did here is I wanted to go pretty deep into this, which basically in the end is the argument against using data classes, but it may be due to my lack of understanding. So I would really like to. I basically made three alternative ways of reading a JSON object and actually sponsoring it back into whomever sent it. And the sort of the most long way is the only way that actually gives me what I want. But it's also a bit weird because I annotate a field to not be null, and then I say, yeah, that thing may be null, which sucks to me. But it's the only thing that actually works. It actually gives me an error when I send ID that is null. It actually says this is wrong, etc., etc. Let's see if I've got that thing open. 5 minutes. That's depressing. So let's look at that. So I remove the ID from the call, and I get a wonderful in 17-fold error that says, somebody give me a handle. Can't get the handle. There it is, just above the line, of course. So I give it I get a huge amount of information that tells me this one field is missing, which is, I guess, what I wanted. Or I should do something with this exception on the back end that makes it shorter. But if I use any of the other methods, I get, again, my dreaded 0 default for missing stuff, and then I try it another way, I get the same thing. So not super happy about that. Does anybody have any experience with that and sort of did this in a nicer way that they solved this? Sorry? I want to get an error when I pass in null for an ID or missing have the field missing. And I would like to say this. And in fact, I would like to also say this. This is going to be set only once. So I don't want this. I want to see this. Doesn't work, but I would be seeing this because this thing is sent. And I don't want to change. I don't want anybody to change this thing because this is what the client said. I don't want anybody to operate on it. I want to have that very, very, very tight in my mitts. In fact, this should be enough, right? The add not null is not even necessary, but let's suppose that I'm sort of flexible, fine. But that should really not be there. So that's what I would like to achieve.
I'm not sure, but maybe this might work.
That's on vars, and that doesn't do well for ints, I think. There was an issue with that stuff. Yeah, it's going to say that it's not allowed on primitive types. So then what I then would do is I would have a bunch of these fields that would be that, but then the ints wouldn't be that, which is also making my face go all frowny and stuff. So yeah, I remember something about 5 minutes. So unless somebody now says, oh, you wanted to do that, that's easy. Just use let. No? Okay.
Kotlin serialization being developed by JetBrains.
Mm-hmm.
X serialization.
Mm-hmm.
Does the JSON formatting for you. I think it does this kind of thing.
Okay.
That's exactly.
Yeah, cool. Thanks. Excellent. So that was some time ago, no, those 5 minutes. Let's go. Oh yeah, about the tests. I don't want you guys to miss out on that, and neither would Adele, right? Transformer test. So very, very, very simple. The most basic form of test is just the thing that, oh yeah, I have to show you the transformer class that transforms a string and does basically what the anonymous function did in the past. I just want to make it simple but have a class around it. So it turns a string into an int, fine. And the test then says, well, assert that transformer is actually the thing. The only thing that's sort of annoying and interesting here is that because this is a keyword, we have to do the backticks thing, which is annoying, but you know, we'll get used to that, I guess. Then we have something that does sort of a dependency injection. So it says, well, this is a service and it gets a transformer. I don't know what the transformer is, but when I get it, I'm going to call that transform on a transformer from a transform function on it, etc. Something about transformers. So how do we deal with that? We make a mock. Now we again get the backticks for when, because there's also a when thing, and we get now sort of a little bit of a nastiness, which is a framework issue that we have to pass in the Java flavor of the class now. Okay, well there are ways and means to get around that, but it basically ends up making a function that does that for you. And again, the is and etc. We can mock that stuff. What is interesting to see is that that class then has to be open. For Mockito to work, it needs to be able to extend that class. So, and if let me see, that's sort of that. Yeah, I can show you what all the stuff that happens when you don't do that. There is an example of a closed class that fails, an open class with a closed method that fails, and then something that's open that actually works.
You can use Mockito inline and it will open all the closed classes for you.
Yes, sir?
You can use Mockito inline.
Inline.
Yeah, there's another dependency instead
Okay.
of regular Mockito, and you wouldn't need to open classes.
And it's instead of the standard Mockito.
Yeah. And
Okay.
there's also Kotlin Mockito, which
Yeah.
is
Yeah, by N. Harman or something like that, right? Yeah. Yeah, I'm using that one as well. But then that doesn't open your classes, I think.
no, it's
That just
two
gives,
separate things.
yeah, yeah. Excellent. Good point. Thanks. Any other question? Yes.
Can Mockito 2 just do that? You can work with file classes or maybe JMocket, maybe with static classes as well.
What's your exact question?
Well, you said you have to make everything else if you use different framework. So
Yes.
you do that, right?
That may be true. By the time I tried Mockito 2, it didn't interoperate well, or it was an experimental feature that did the class extension in that. I don't know if it's stabilized now, but
I've been using JMocket for the last year,
okay.
and yeah, so just incremental.
Okay. Oh, that's good. That's a great one as well. Thank you for that. Great. Okay. We are probably in the negative on the amount of minutes left, so let's go on. Oh yeah, future lessons. So I'm almost there. That's good. So the fancy stuff we haven't used yet. So we didn't use the coroutines. I heard one or two people be really excited about that. We don't use lazy evaluation yet, although it's a pretty nice feature. And there's an example which I would show you. We don't use the Kotlin DSL instead of the Gradle standard one. I looked into it shortly, but then I ran into API troubles, and I was like, Gradle still has some issues. We don't use DSLs in general, and we haven't looked at Kotlin native or any other of that. Other language stuff, so not on the client side, not on the JavaScript side either. Concluding thoughts, yeah, it's 3 lessons. I hope that's come across, so it's cool. I really like it. I really enjoy that it's so easy to learn. But if you do this, do it step by step. Really have the advantage of using Java and Kotlin next to each other for some time at least, to make sure that you're not inside of a new world where you're like, yeah, I used to be a really good Java developer and now I suck at this, so sorry client, you have to wait for 3 weeks before I figure this stuff out. Don't be at that point. That's not good. But the problems that you will hit are really minor or really limited in number. So yeah, that's it. Good.
Good evening. Hello.
Hello.
Hi. Nah, don't answer. I'm just testing the mic. Good. Right. Friendly reminder about the chocolates, which I'll forget, so I'm going to put them in front of me here so that I don't see them, and that way you remember them and I won't forget. I have to give out chocolates. Okay, so welcome to this talk on Kotlin 102, or yeah, I don't know where I came up with 102, but I knew that they used this Kotlin 101, so I thought, well, 101 means intro, so 102 probably doesn't mean intro. Apparently that's not how it works, but hey, who cares? Anyway, I'm going to show you a few things in Kotlin that are not 101. You've already seen a few things here, so I'll try and not cover too much details of what you've seen previously to me, which is kind of unfair because that was the first time I saw it as well. So I'll try and improvise. And if I don't, you won't know the difference, so it doesn't matter anyway. Right. So this is a file. This is as big as I'm going to go with the font. Right. I know that you can see it now. Hopefully in the back you can see it. If not, okay, if you can see it, I'm going to turn it down a notch because I can't actually fit anything on the screen. You can still see it, right? Okay, should we start with 31? No, I'm joking. Okay, so I'm going to start with a few different things, show you some things around Kotlin which you don't get in an introduction course, although Kotlin as such isn't such a complex language. So really, it's easy to essentially pick up. But let's dive in a little bit to a higher order function which you're all familiar with. So I have like a function that takes an integer and another integer and returns an integer. And that's a higher order function, right? So it's a function that takes a function or a function that returns a function. And in Kotlin, we can have multiple functions. So I can have, for instance, a G over here that takes no parameters and returns nothing. Returns unit, which is actually different to nothing, right? It truly is. Unit is not nothing. Unit is an object, which is different to a class. So how many of you are JavaScript developers here? And not too embarrassed to put up their hands. Object is equivalent of object in JavaScript. You know how you went from Java or C# to JavaScript and you're like, oh, I'm going to take everything I brought with me, so let me create this amazing system in JavaScript called classes and hierarchies, and everyone's like, no, don't do that. You have objects. In Kotlin, we have objects and we have classes. Object is essentially a singleton. This is how you implement a singleton in Kotlin. You just write object. That's it. You don't have to buy a book. Which was a good book, by the way. Although nowadays you can't say you've read The Gang of Four. They'll frown on you. They're like, oh, you're not doing functional programming then. So, and I was saying that it's not nothing, right? Because nothing is something in Kotlin. How many of you have heard of nothing? Okay, so nothing is something. So this is do something that does nothing. And if I have unit and I do throw exception, this does nothing, right? Because if I write, it does nothing. Well, it throws an exception. But if I come to my main function here and I say print line hello, that will work. If I write throw exception blah, that won't. And if that will throw an exception. And if I write by, the compiler will say that this doesn't work because it's never going to reach that code because exception being thrown. So, but if I write here, do something, it's going to not work as well because it's got the exception. However, if I remove this and I take this line over here and I move it down, print line is still going to supposedly work, right? Because it's saying, well, it's going to work. It's going to call a method. It's going to come back. And that's the difference between unit and nothing, because nothing actually says that this function is not going to return. It's going to essentially be nothing. And there, now it says that this code is unreachable. So there is a difference between unit and nothing. And as I always say, nothing is nothing for you to worry about. So let's move on. So we have this do something, and we have this higher order function. And one of the things that we have in Kotlin, if you're familiar with, obviously you've got the string extension, you've got the function extensions, but you also have property extensions, right? So very good example of this is always like I can have a long that I can write or a float that I can write using literal, so I can write 10f. That means that it's an actual float. And when we work with big decimals, which we love to work with, I want to be able to write big decimals is 10 BD. I cannot do that because there's no such literal for big decimals. I could do the next best thing to that, which is create an extension property, right? So, well, I could create an extension function, right, but it doesn't look that good, but I can create an extension property. So I can create an extension to integer, for instance, that returns a big decimal, and then this is going to return a big decimal of this, right? So that is giving me an extension property, okay? So one of the benefits of this is that, apart from making it very nice to look at, is that you can essentially delegate the functionality of a property to something else, right? To an external function which you can reuse over and over again. And that's one of the benefits of delegated properties, right? So I have a class with a bunch of delegated properties, and I can delegate these to other functionalities and then share them across multiple classes. And that's where we have, for instance, a bunch of built-in delegates. So you're all probably familiar with the lazy delegate, right? How many of you are here familiar with lazy? So lazy essentially is lazy initialization of a property, right? It's going to initialize it when it's accessed for the first time, and it's just going to initialize that code, and it's not going to run that code ever again. And that is done by using declaring the property lazy, and then using by, and then lazy, which is the built-in delegate, and then I pass in the actual function that is going to initialize that property. So if we go over to lazy over here, we can see this is a higher order function that takes an initializer. It also has overloaded versions which allow you to pass in the different type of initialization that you want to do, synchronization on shared properties. But that's one of the most common ones. But there's a few other ones that are also built into the standard library, right? One of them is the vetoable. So vetoable is a delegated property which allows you to say if a certain condition is matched, then update the property value. If not, do not do it, right? Without you having to write that logic over and over again. So in this case, I'm saying that I've got the property, I've got an old value, I've got a new value, and I say that if the new value starts with an S, then update the value. If not, then don't update the value. So here, where we're creating, for instance, a class veto, and then I say set the value, I set it to change, I print out the value, I set it to strange, I print out the value. In principle, the value should only change after I hit strange, right? So if we run this, you can see that on the first call, it's not actually setting the property, okay? And it's setting the property on the second call over here when I hit strange. So this vetoable, lazy, and observable are some of the built-in delegates that we have in the standard library, which you can use. But of course, you can also create your own property delegation in Kotlin. And essentially what you have to do is you have to create a class that defines two operators. One of them is called getValue, the other one is called setValue. And much like you saw in the vetoable example, what I'm getting here is some information about the actual class, then I'm getting information about the property. K property, what is K property? That's just like property, but prefixed with a K. That's it. And that's one way to explain Kotlin. Take everything Java and prefix it with a K, and then release libraries with a K, intercalated with a C, no, that one with a K, and that's Kotlin. So K property is a Kotlin property, so it's essentially reflection enhanced. Right? So in Kotlin, you might be aware that you can use Java reflection. You can also use Kotlin reflection. It's like Java reflection, but better. It's got some additional things that has intrinsic knowledge of Kotlin, such as properties. So this is how you can create your custom delegates, and then essentially just use these delegates anywhere you want in your own classes, properties, top level, variables, etc. Okay? So one other thing that we have in Kotlin is algebraic data types, or we represent algebraic data types with CIL, right? So here is a simple example of what would be an algebraic data type, which if you're not familiar with that concept, an algebraic data type is a type that can be of one type or another. For instance, Boolean. Boolean can be of type true or of type false. So in Kotlin, you can essentially do the same thing by declaring this as an open result, right? So here now what I'm saying is that my class can inherit from result, and I have two cases. This is very common, for instance, if you want to move away from exceptions or you want to have a function that returns one of two different types in case of success or failure, you could do something like this, right? And if you do this, this is absolutely valid. The problem with this is that if I come here and let's go over, for example, to a file and I say class sometimes and sometimes inherits from result, right? That is going to work as well, right? Because result is an open class. So if I'm writing code that is checking for that, that kind of sucks. What you can do instead is mark class as sealed instead of open. And sealed, essentially, what it means is that it's closing off the hierarchy. Okay? So now you cannot inherit from that class beyond what you've already inherited. And you might be asking, what is that? Well, whatever is on that file. So sealed will close the hierarchy off to that file, right? So over here, sometimes no longer works. But over here, sometimes does work. And this doesn't necessarily need to be up top level classes. You can also have it as nested classes. Do you have a question or did I answer it?
No, a question about something else. Can you lower the volume a bit?
Oh, I'm too loud? That's what my family always says to me. I'm sorry. I'll try and talk a little bit calm. Is that better? That's better. So you're sitting there like suffering with pain. I'm so sorry. So I have tinnitus. Now you know how I feel. Except it's not my own voice. It's some damn ringing. Anyway. So I'm also happy to know that my explanations are so awesome that you only care about the volume. That's like recently I was giving a webinar for 1 hour, right? 1 hour webinar. And I had, of all people, one of my heroes, Eric Meyer, as a moderator, right? So 50 minutes in, nobody's asking questions. And eventually Eric says, Hadi, we have a question. I'm like, oh, yes, what is it? It's on Kotlin, right? The webinar. They're like, yeah, someone's asking what is that arrow in IntelliJ IDEA? Anyway, when I grow up, I want to be a programmer. Numbers 1 to 100. Now, you all know that in Kotlin, if I write something like this, and then I do, for instance, numbers, filter, it is less than 10, or let's say it is divisible by 5, if I could type, and then say take 30, what's going to happen here is what? This is eager evaluation, right? So essentially, it's going to look through the entire list, and then it's going to filter out those that are divisible by 5, even though at the end of the day, all I want is the first 30 of them. If you want to have lazy evaluation, that is possible in Kotlin. All you need to do is take any iterable and call as sequence on it. As soon as you call as sequence, that now becomes lazy evaluated, right? So essentially the same as Haskell, where everything is by default lazy evaluated. So this works with essentially anything that is an iterable. If you actually navigate to as sequence, you can see that it's just an extension function on iterable. So any iterable collection, anything you can basically convert to as sequence and then chain all of the wonderful methods that you have when you're doing method pipelining. So what happens in the cases when you cannot have an iterable to begin with? For that, we have other functions as part of the standard library, namely generate sequence, which has two versions, one of them taking a seed, and then on that seed you can do whatever you want, and then from there, again, filter, and all of this, again, will be lazily evaluated. Okay? So there's two ways to do it, as sequence, or if you don't have collection to begin with, you can use the generate sequence. Okay. Now, in the previous thing, you saw type aliases. What? Am I still too loud? Oh, okay. Oh, you're scanning. Okay. Right. So in the previous one, you had type aliases, and one example of when you want to use that is, for instance, that you said, I want to have a handler that is a function that goes from string to string, for instance, right? if I knew how to write Kotlin code. Or forget it, I don't. And that is one use. I actually don't like that use as much, because one of the things that I like around Kotlin is the discoverability. When you look at a function, you exactly know what the parameters are. So when I look at a higher order function and I see int of int to int, I exactly know what it's going to take. I don't have to introspect the type to actually understand what it's going to take. But one other useful case of type aliases is for using it with deprecated. So how many of you write here APIs? And you ship those APIs to your customers, even that's internal. And you love to break your APIs. And then, you know what you can do? You can actually sell subscriptions on it, and then that way you can always upgrade. So, for the record, JetBrains doesn't sell APIs. So one cool thing that you can do with APIs is, let's say that I have a class. So let's go ahead and actually remove all of this nonsense over here. So let's say that I have a class called customer, right? And then I have a main function that is using this customer. So I say, well, customer equals customer. Now, tomorrow I want to come and rename my customer to awesome customer, right? Now, if I rename this, it's going to break my APIs. So what I could do is introduce a new type alias, which is awesome customer, right? Which is essentially a customer. Okay. And then what I could do is come to my customer class and add the deprecated and say, customer is now awesome customer, right? And see, as soon as I do that, when I add the deprecated, the IDE is going to highlight this and say this is an awesome customer now. But the good thing is that I haven't broken my API. So I can do a phased upgrade, right? I can introduce a type alias, have people switch over to that, and then eventually in the second version, remove that type alias. And in fact, if you've been on board with Kotlin, for many, many years, back when we used to call interfaces traits, I want to actually make out a t-shirt that says I was using Kotlin when it was traits. We did this phased migration. For every M release, we do this phased migration. We first give you a warning, and then the next release is going to be a compiler error. And you can actually use the IDE to fix this for you. So you can say that replace this with awesome customer, and what the replace with does is that now it gives you the magically Alt-Enter, right? So you now have the replace with awesome customer. So that's one other use that you could use for type aliases, to do a phased migration. Okay, some things around inline functionings, right? So let's go to our high order here. We've seen it, right? So in this case, one thing that we have with Kotlin is inline functions. And in fact, if you look at a lot of the functionality in the standard library, you can see that many things are inlined, right? You can see that a lot of these functions are inlined. And the reason for this, if you, who's familiar here with inlining? Right. So for those not familiar, inlining essentially what it means is copy-paste, right? So instead of me calling, when you invoke a function, when you call operation, instead of actually invoking and having all of the call stack associated with that, what it's going to do is going to copy that function and paste it exactly where you're invoking it. Okay? So it makes sense to do this with functions that are small. You don't do this with functions that are 200 lines of code. Now, of course, if you have functions that are 200 lines of code, your problem is, why do you have functions that are 200 lines of code, not the inlining? Now, with Kotlin, it only really makes sense to do inlining when your functions are higher order functions, not just general functions. So for instance, if I were to create a function here called fun, my friend, and this function has an integer, and then I add an inline to it over here, you can see that the compiler is going to give me a warning, and it's going to say that my friend inline is insignificant. The performance gain over inlining this function is insignificant. Inlining works best for functions with lambdas as parameters. Okay? In this case, it's not saying it because I actually have a lambda as a parameter. So what this means is that when I create this inline function, it's not only going to inline the actual call to this function, but it's going to inline the parameter as well. Right? That's where you get some of the benefits. Now, inline functions give us another benefit as well, which we'll see in a moment. But there are times, for whatever reasons, namely, for instance, you want to be able to hold a reference to an inline to a higher order, to a function that's being passed in as parameter, which you cannot do with inline functions that are being passed in the lambdas. All you can do is essentially invoke them. So there are times when you want certain functions to not be inlined, which in this case you can decorate it with a no inline. So if I have, for instance, another higher order function here, I can decorate the second one with no inline, right? So now it's saying that while inlining is applicable in this case because I have a lambda that is being inlined, for certain cases I don't want it to be inlined. Okay? There's another one which is called cross-inline, which I'm not going to give you the explanation of because for that you're going to get a chocolate. So go and Google it. So the inlining also gives us certain benefits, right? And it also changes somewhat a behavior. And that's where we come to returns. So here I have a function which is called containing function. And it basically loops through a list of numbers, and then it's going to do a return. If I were to run this, what do you think the output of that would be? Nothing? No, it doesn't return nothing. It returns unit. I'm joking. Who says nothing? Who says hello? Who says it's me? No? Don't get it? Adele? No? God. I'm sorry. That was bad, no? Okay.
It's all right, I've heard worse.
Yeah. You've heard worse, no? Okay.
I used to work at a call center. Heard it all.
Oh, yes, and you're called Adele. All right. Yeah, that must have sucked. Okay, so if I run this, it doesn't return, it doesn't print out, it doesn't run. What did I do? Oh, G parameter. G, where's my G? Up. No, just remove that. That's what happens when I do live coding. Okay, so back to returns. If I run this, it's going to return nothing, right? It doesn't print anything. Now, before we understand why, take a look at this example. This is my inline function that is an iterable of my for each. And this is exactly the same as for each. In fact, if you navigate to for each over here, right, let's do a split vertically, and then I'll switch back to returns, you can see that my for each is essentially the same as the for each here, which now died on me. But anyway, it's exactly the same, trust me. If I run containing function with my for each, what do you think it's going to print? Hello? Or it won't print anything? Well, if it's exactly the same as the other for each, it's going to not print anything, right? That was like a trick question. It's not going to print anything. However, notice one thing. I wasn't going to run this. If I remove the inline, I can't return, right? And this is what's called non-local returns. The fact that this is returning outside, the fact that it's not printing hello is because the return is returning from containing function. Why is it returning from containing function? Because for each is an inline function, therefore it means it's essentially copying pasting the code inline, and when I call return, there's only one function to return with, which is the containing function. So what happens in this case? Well, in this case, you can't actually do a non-local return because returns are only applicable directly when invoked like this. They're only applicable to inline functions. Now, what happens if I want to actually return to the containing function and not to the invocation of the containing function? I use a label. No, this is not a GOTO. Please, it is not. Okay? This is not a GOTO. It's a nicer GOTO. It's an at. So I use at. An at is the actual name of the function. These aren't built in labels, right? If my function was called my for each, then it would be at my for each. And in fact, you can prefix it with a label as well. I can give that lambda a label. So I can say my label and then return at my label. Now, if you're not aware, in Kotlin, we have lambdas. Well, you know, we've seen them, right? This is a lambda. I mean, whereas my higher order, if I write main, this is a lambda. So if I write higher order, f, and then x to x plus something, this is a lambda, right? This is a lambda, which in many languages is called the same as anonymous function. In Kotlin, it's not. We have anonymous functions as well. This is an anonymous function, right? It's literally the same as in JavaScript. So I have a function with no name where I can pass in the actual parameter name and then do a return. In the case of an anonymous function, it does perform a local return as opposed to a lambda. So, meaning that if you want local returns, you can either use labels or anonymous functions. Okay? Yes?
Why was labels included?
What do you mean?
Why is there labels in the function? Why do I have to argue with people making about it?
Oh, you don't. That's why I just showed you. You can use anonymous functions. That's a question best asked from Andre, I guess, not me. There's a lot of reasons that we do some things in Kotlin. Some of them are for performance reasons. Others are for tooling. Take into account, though, a lot of times when people say to us, why should I use Kotlin if Scala is just like Kotlin, but it allows me for more things? Because the flexibility and the versatility that Scala has, it also makes it extremely hard to do tooling. And performance-wise, it's not as performant, right? So there might be some reasons sometimes that we do it for performance. Other times it might mean we're doing something because we're going to later add another feature that be able to distinguish, we're using this ahead of time, right? Okay, now with the inlining, I said that inlining is good for performance reasons. The other one is for reification of generics. Okay, so if you're familiar with the JVM, which you probably are, you know that we have this minor little problem called type erasure, right? So what you can do with Kotlin is any inline function, you can add the reified keyword to it, and that will then allow you to do certain type checking on the generic type, right? So in this case, I can say is input of t. If I remove reified, it says to me that I cannot do this. Okay. So reification, and if I remove reified, you see that I get the warning again, right? It says the performance improvement here is minimal because you don't have a lambda. Yet that does not appear when I'm using the reified, because it does allow me to get some information at times. Okay. One other thing we have in Kotlin is, well, you have this in many languages, but is variance, covariance and contravariance. So here's some code. This is a mutable list of any, and this is a mutable list of string. And if I uncomment this, is this going to work, yes or no? I'll give you a hint. The reason it's commented out is because I always check that this project compiles before I do the demos. So it's not going to work. Why is it not going to work? So I have a string is a subtype of any, but variance. It's type invariance. But why doesn't it work? Explain to me why this won't work.
Because you can a string is a subtype of, any is a subtype of string, but a mutable of any is a subtype of a mutable of string.
Right, and that's what this is saying. But yes.
You could declare your elements as a mutable list of objects. Then you could assign your strings.
No, I'm not saying how to fix it. I'm saying why doesn't this work? Oh, okay.
Just because it's not allowed to do that. Because if it would be allowed to do that, you would assign basically any object to the list of strings.
Yes, yes. And imagine a much easier example for you to see this. It would be very obvious is if you're passing a mutable list to a function, and you pass if a function of type any and you pass of type string. The function is of type any, so essentially inside that function you could add anything to that list, right? Because it's of type any. And yet if you're passing an array of string, you can't add a number to an array of string, right?
Is that chocolate worthy answer?
No, I just told them the answer. I've got better ones for chocolate.
Maybe you should take this one then.
Thank you. I will. Is it dark chocolate or is it milk?
It's milk.
I don't want it.
Good.
No.
No, I'm in the same boat, man.
So now this does work. Why does this work? Because it's immutable, right? And by default in Kotlin, list collections, they're all immutable as opposed to mutable. That's why you have to write mutable. Okay. Now in Kotlin we don't have we have call site variants, but what you can do is you can declare certain types like this list here. This list is, if you go to the declaration, you can see that this list is contravariant, right? Which is indicating that what we've just done is possible. And in Kotlin, this is expressed with out, okay? So you have out and you have in. So we have declaration site variants, which means that we declare the covariance or the contravariance of that type at the declaration site. You also have use site variants when you're interoperating with Java, for instance, or in a specific function. You can call use site variants. But generally in Kotlin, you do declaration site variants, which means it's great because I don't have to have this question mark extends and all this that we do constantly in Java. The rule of thumb here is really simple, is if your class is only consuming, then it's covariant, and in fact the IDE can tell you, it says that you're only consuming here, so you can add the in to make this covariant. If you're producing, then it's going to be contravariant and you would add the out. Okay? So to summarize, you have covariance and contravariance, you can declare it at the declaration site, and you can also use it in specific cases on call sites. Now, let's get into some of the other things around Kotlin, which is DSLs. Okay, so let's do some coding here. So how many are you familiar with DSLs, domain-specific languages? DSLs are awesome. DDD, me, Scott. I don't know why I wrote Scott. GOTO. Okay, there you go. And that's how we name things. I'm from Spain. I didn't mean that as an insult. No, and one time I was going to, I went to a company before I joined Jabra. I was doing consulting, and I went to I tell you this story because this is really, really true. I went to a consulting company, and I was doing a code review, and they had a function which was called, so anyone speak Spanish here? Okay, you all speak Spanish. So it was called Fecha Manolo, right? And Fecha Manolo, Fecha means date, and Manolo is Manuel, a name. And I said, what is Fecha Manolo? And he said, it's a function we've written for Manolo. Because Manolo wanted the date in this specific format. And I said, but there's two Manolos here. And they said, no, he's Manu, which is short for Manolo, Manuel, and this one's Manolo. I said, so what happens if you want a variation? He says, well, we'll just call it Manolo too, right? And I kid you not, this is the code that's out there. Anyway, so you all know about function extensions in Kotlin. So I can write is same as value string, and then I do, for example, this equals value, right? And if, again, I used to know how to write Kotlin code. There you go. So this is an extension function, so I can say no, or this is same as this, right? And I can do this in infix notation as well, which I can just write it like that and get rid of that. And the best part about doing demos in Kotlin in IntelliJ is because I don't even need to know Kotlin. I just hit Alt-Enter, and I can get that in infix, and now that is awesome because now I can call this in infix notation, and you start to say, oh, this looks nice. It looks like kind of like DSL-ish, right? Or a BDD. Okay, so this is the typical thing that you see in Kotlin, right? Now, DSLs go a little bit further with Kotlin. And what we can do is, let's try and create, for instance, a DSL that allows me to create a framework around web development. How many of you are familiar with Express.js or Ruby or Sinatra and stuff like that, right? So I want to basically create a function that has, for instance, a get that takes a path of type string and then takes a handler, right? And the handler is going to take, for instance, a request, which is an HTTP request, and a response, and it's going to return unit. And then I'm going to have a class request that, for instance, takes a property of type accept, and I'm going to have a class response that takes, for instance, a property status code of type int and a var content of type string, right? So now I could do something like get home, and then now in Kotlin, remember, if the last parameter to a function is another function, what can you do in Kotlin? Well, instead of enclosing it here, you can enclose it outside of the brackets, right? So I could enclose this over here, okay? Okay, and let's rename this to get root, for instance. Get root. Okay, why is that giving me an error? The what? The request and response. Oh yeah, okay. So yes, so now I've got to do request response, and then I have to do, for instance, if request accept equals application JSON, right? Then whatever. Like for example, response content equals some JSON, right? And I love escaping key. By the way, you know how to write JSON in IntelliJ, right? Alt Enter, inject JSON, and then you do Alt Enter, edit JSON fragment, and then you do it like that. You don't sit there and do escaping of characters. Okay? So now this is nice. The problem is that I have all of this horrible request response and the curly braces and all of that crap, and this looks kind of sucky. Now what I can do is I can replace this with handler, for instance, right? Create a type called handler. That handler in turn takes a request object and a response object, right? And then what I can do is, since in Kotlin I could potentially, if there's a single parameter to a function, replace it with it, I could get rid of the explicit declaration here, and then this one prefix it with it, right? And then request would become request, and response would become response, okay? Now that looks nice, but again, it's that wretched it that I want to get rid of. So, how can I do this? I want to do just like if request. How can I do that? So you're all familiar with higher order functions, right? Higher order functions are what? Functions that take other functions or return functions. What else do we have in Kotlin apart from functions? We have extension functions. So why not combine the two? Why not create a higher order function that doesn't just take a function but takes an extension function? So what I could do is, instead of this taking a function, I can say that I want getRoot to take an extension function. And the way you do that is by prefixing it with a dot, similar to how you declare an extension function. So now I'm saying that getRoot takes an extension function. Now, given that this is an extension function over here, this means that this lambda is what? It's a member of handler. Since it's a member of handler, what does it have access to? It has access to properties of that handler, meaning that I can get rid of it. Okay? And I have my nice little, much nicer syntax here. Okay, following me? Good. Now, this is also nice, but I want to go one step further. What if I want to do something like that? What if I want to do something like that, right? Content. Now let's follow the same pattern. The problem here is that response is now what? It's a type. And essentially what I'm doing here is I want to do what? I want to invoke a type, right? Because this is a lambda. So I'm saying, how can I invoke a type? That's not possible. Actually, it is. In Kotlin, you can create a class foo, and then you can say, I want to create a new instance of foo, right? And then in foo, I can say hello. And then this will say squiggly, and I'll say no. And what I'll do is I'll create an operator that is called invoke. So that now allows me to invoke an instance. Given that I can invoke an instance there, well, why don't I just do the same thing here? Why don't I invoke an instance? How do I do that? Well, what is response? Response is a type. So all I have to do is create an operator, invoke, for the class type. And I'll just tell IntelliJ to do it for me. Now comes the question of what do I pass in as parameter? Well, what do I need here? I need content. What is content? It's a property of response. Therefore, I create this as an extension property to response, meaning I now have my content. Okay? And that's how you create DSLs in Kotlin. Okay? Now, this is just one sample DSL. And the beauty here is exactly what we've seen, is that when we talk about DSL, people quickly think, oh, I'm not going to create my own HTML. No, you're not. The beauty of DSLs is the small DSLs that you create across your application, right? If you combine this something with Alberto's workshop around domain-driven design, what is one of the ideas behind domain-driven design? Sorry, that's a different workshop. About domain-driven design, the idea is to have this concept of a ubiquitous language, right? Where the business aligns with how you write code. Think the potential you could have here, right? You could have the Dutch tax office define their own rules in Kotlin. It's like mind blown. I was actually at the Dutch tax office and I told them this. So, and they said they're going to start looking at Kotlin. So there you go. The deal was if I moved to Amsterdam, I'd get like a massive tax break. No, I'm joking. That'd be cool.
Do it anyway.
Do it anyway? Yes. Anyway, so that's kind of like the DSL stuff in Kotlin, right? And this is where you can use this stuff to create wonderful little DSLs for your domain-driven design, for your configuration files, for all of these things. We've used this extensively. So for instance, in TeamCity, which is our continuous integration server, we have now created DSL that allows you to define all of your configuration using Kotlin, right? Gradle has adopted this for the same purpose. Okay? Any questions? Yes? In what sense would it be performance?
Is it performance-wise better instead of not using extension functions?
I don't think that it is appreciated. I don't think it is like it would be minimal in that case. I don't see an issue in terms of performance there. Okay, quickly, I've got a few minutes left, right? So I'll show you quickly some things around. What is this thing that we're going to see? Coroutines. Yes, coroutines. Okay, how many of you have looked into coroutines in Kotlin? Right. Coroutines are great. They're the best way to do things. I'm joking. I don't have internet, so I can't put my wonderful slides on. But how many of you doing asynchronous programming? Right. Now, how many of you do threads and love it? JavaScript, callbacks, love it. JavaScript part or the callbacks part? Right. So threads are complicated. We all know that. Callbacks suck because the problem with callback is that you have a function that once it's completed will call back another function. The problem, of course, we all know is that it's not just one function. That function will then have to call another function as a callback, and then another function as a callback, and so on and so forth. And welcome to the wonderful world of JavaScript, which looks like a tilted Christmas tree, right? Because when you put all of the little, arrows like this, it looks like a Christmas tree if you look at it horizontally, right? And then, of course, in the world of JavaScript, normally with callbacks, error handling is also problematic, right? So usually the first parameter in JavaScript by convention was E for error. Of course, some people think E is event or E for exciting, so they don't even handle errors. So in Kotlin, we've tried to take an approach to asynchronous programming and concurrent programming using this generic concept which has been around since the 70s, or if not earlier, I think the 50s, called coroutines, right? Or suspendable computations. Under the covers, coroutines are essentially the exact same thing as callbacks, except you're not worried about doing the callbacks. It is the compiler that is doing the callbacks, right? The compiler under the covers is creating a state machine, making sure where the when a suspendable function is called, it can essentially resume at some point, where it can resume. All of this is taken care of for you under the covers by the compiler. And the way that we've done it in Kotlin is essentially by adding a single keyword to the language called suspend, right? And the suspension, this function is over here, is this keyword here, suspend. And what suspend means is that that function essentially can be suspended in some point of time, and then at some point resumed. Okay? So think about a function that you can pause and resume, right? Coroutines take this idea of having suspendable computations where I can call a function, suspend it, continue something else, resume that function, get the information back, and so on and so forth, and doing this at compiler level, meaning that you do not need any primitives, meaning that if you are targeting JavaScript with Kotlin, targeting the JVM with Kotlin, you don't have to worry about one platform having threads, one platform having not threads. All of that is taken care of you under the covers by the compiler. To understand how it does it with lightweight threads. And when I say lightweight threads, I mean it. So here is an example where I have 1 to 100,000 jobs, which are essentially threads that I'm launching. And I'm going to do a thread sleep, and then I'm going to print out a dot when that thread sleeps, and I'm going to run this. Okay, so I'm going to run threads. Okay, I'm going to run this. What do you think the result's going to be? Out of memory. Yes. And look at my awesome neon cat thingy. Out of memory, unable to create new thread. Okay? So I'm going to do the same with coroutines. And coroutines, you can essentially see that it's exactly the same thing, except instead of 1 to jobs, 1 to 100th, I've created a list. I've got this little thing here called launch that you don't need to worry about right now. I've got this thing called delay, which is essentially the same as thread sleep. And I've got print. If I run this, what do you think is going to happen? It's obvious, right? Because if it failed, it would be a really shitty demo. So this is actually going to run, and it will finish. And it's printed out 100,000 threads, right? And in fact, I can print out 1,000,000 threads, right? And it allows me to catch my breath. And what this is doing is really lightweight threads, right? So it's suspending functions, doing the work, suspending, doing the work, suspending, resuming back. And it's doing this by trying to do it in a way that is familiar with the way you already code. So the main idea behind coroutines is that I continue to work the way I have usually worked, okay? With no having to learn about new operators, with not having to learn about new ways of writing asynchronous code. Have any of you played with RxJava? Right? So RxJava, the first time they introduce you to RxJava, they say to you, everything is a stream and it's observable. And you kind of think, what the hell did you just say to me? Right? And the idea is that you move away from discrete value, you move away from a specific set of values to a stream of values that you continuously can subscribe to using what's essentially an observable pattern. Right? Rx is pretty much an observable pattern with a series of operators on top. And if you have done Rx, you know that you have to have a mind shift. You move away from one certain way of programming to a different way of programming. With coroutines, the idea is that you do not do that. With coroutines, the idea is that you continue to program the same way that you would. In fact, take a look at this code, right? This code is calling 2 functions. And measure in millimeters is a standard library function that just measures how long some code is going to take. And then I'm going to call function 1, function 2, and print out the result of 1 plus 2. This function has a suspend. It's got this magical thing called suspend, which means it's a suspending function. And this one has a suspend as well. If I run this, how long do you think this is going to take? 1 second? Let's run it. It's going to take neither 1 nor 2. It's going to take 2015 milliseconds, which is slightly over 2 seconds. So yeah, it's going to take 2 seconds. The point being is that this is exactly what you would come to expect. I am running a function, and then I'm running another function. The idea behind coroutines is that I continue to work the way I am. Then you're saying, then what's the bloody point of all this? Because this is not running on the main thread. It's potentially not blocking the main thread anymore. Why? There's this thing over here called run blocking, which is going to block, but forget the name. It's going to block the main thread until any coroutine launches. So let me get to that. So this is a suspending function, right? I can't just come and have a main function here. If I take a main function here and I say function 1, it's not going to let me call it because this says this is a suspending function. So the function that calls this needs to be able to know how to handle suspending functions. So you can only call suspending functions from other suspending functions. The main entry point to an application, you could use something like run blocking or some other mechanism, which you will see. But run blocking is kind of like a helper method that allows you to invoke suspending functions. The fact that this is doing this means that it's no longer blocking the main thread. You had a question?
What's the difference with thread.join?
Thread.join is essentially waiting for the threads, right? Here there is no thread.join. In thread.join, in what sense is it different? Like in thread.join, you are launching 30 threads, right? And then you're waiting for them to join, okay? But you have to, at some point, wait for the threads to join. And you're launching threads, okay? In this case, to the practical, in terms of the result, it is not, there's no difference. The difference is that there are no threads here, okay? These are lightweight threads, so to speak, okay? But the point being is that this is top-down. It's no magic. Because one of the things that we favor in Kotlin is that when you want concurrency, you need to be explicit, right? And this isn't concurrent. This is sequential. So how do I do concurrent? Like this. In concurrent, I have a syntax called async. And async is not a keyword of the language. Async is essentially a library call, part of the Kotlin coroutines library. And async, what it's doing now, in this case, it's saying that, yes, this function is now asynchronously called. So in this case, it's going to run this concurrently, meaning that the time is going to be 1 second, right? If you're familiar with C#, this would be similar to the async await in C#. The difference is that here I actually can get the value as opposed to getting a task and then inspecting the value of that task. And you can do some cool things with coroutines, like for instance, even have asynchronous calls that are lazily evaluated. So for instance, here I'm defining one function 1, one function 2, and then I say result await and result await just like before. The difference is that I'm passing in a parameter called lazy. What does that mean? That means that it will only initiate this coroutine when it is needed, which means when await is called. Meaning that in this case, this would run 2 seconds, right? Because until await is not called here, it doesn't actually need to call it, okay? So, coroutines, yes?
What's the common pool?
The common pool. So the coroutines use these lightweight threads, so to speak, and you can launch these in different contexts. So common pool is one, like a common pool of threads, so to speak, that you could launch this in. And then there's different parameters. You can have, for example, unconfined, meaning that it doesn't matter where you launch it. You can launch it in one place and resume it in another. This is essentially restricting it to a specific common pool. You could also create your own threaded context and have it associated to that threaded context. The point being here is that, can I go 2 minutes overboard? Yes.
For you, anything.
Oh, thank you. The point being here is that I should have done this when I started launching Android Studio. Actually, no, I should have launched the emulator before I even flew out from Malaga. The point here being is that when you're launching a coroutine, when you pass in common pool, I can actually pass in other things. Are you familiar with RX Java? So subscribe on, publish on, kind of similar. And I can actually launch on the UI thread as well, right? So here's an example. This is it for me for Android. Like I know nothing more than how to launch this app in Android, okay? And this is the only time I ever open up Android Studio. So this is Android. This is an application that essentially is launching Fibonacci on the main thread, so to speak, right? And it is calculating Fibonacci sequences on the main thread, and every time I click this, it is calculating a Fibonacci sequence, right? And you see that the UI is updating. And when I keep clicking this, it keeps updating, and it's updating this on the main thread. So I don't even have to worry about that because it is taking care of making sure that this is coming back on the main thread. So that's the context parameter that you're passing in. Yes, similar, yeah. Okay? So yeah, coroutines are a separate library that are shipped as Kotlin coroutines. When you try them, please try them now, please use them. When you first try them, the IDE is going to complain and say, this is an experimental feature. You can see that. It says experimental. Fix that by just say, there you go, you just add this, and then they're no longer experimental. Everything's wonderful. The reason that we made it experimental was because marketing wasn't involved, and it's the completely wrong word. It's completely maintained. We are using it in production. In fact, there's a new framework that we've created from the ground up for Kotlin web framework called KTOR, which is using coroutines from the ground up. We're using it in production code. We will maintain it. So don't worry about that experimental flag. Just ignore it. It's not there. It's not part of the standard library. It's part of the library called coroutines, Kotlin X, kotlinx.coroutines. The only thing we added to the actual language itself was that keyword called suspend. Okay? That's it. Any questions? Yes?
So if you have any IO in this coroutine functions, is it going to block the thread?
No, that's what I just showed you. So you can launch it on the, you can update the UI if you launch on a UI thread.
So let's say I'm reading a file and then it will be smart enough to not block the thread.
Correct.
And it's so it's kind of magical in this. In that
It's
sense.
not magical, but yes, that's the idea. The idea is that you do not have to go to great lengths to write code without blocking your main thread and continue to write essentially imperative code.
And it actually creates a new thread that is lightweight for each coroutine.
No, it doesn't create a new thread for each coroutine. What it's creating is a state machine, right? So it's executing code and then putting it back on the proper thread. So for each time, essentially under the covers, what it's doing is taking your suspend function and creating a new function called with a callback. So it's doing a callback under the covers, and then a compiler is keeping track of that state. You had someone over there. Yes. Why do I need Android Studio? I don't. I use IntelliJ. You mean to launch that demo? I know, but yeah. It's so that people say, oh, you use Android Studio as well, no? And that's it. Yes.
Can you cancel the routine?
Yes, you can cancel a routine. In fact, what you do is essentially each coroutine gives you an access to a whole bunch of properties. One of those properties is called isActive. So essentially what you can do is query for an isActive. You have to design your coroutines to check for isActive. And then you can, at any time when you call coroutine.job, when you launch a coroutine, it gives you back this thing called the job. And then job has a function called cancel, which you can cancel.
You can also wait for it.
Yes, you can also do timeouts as well.
Can you know when it's actually canceled?
Correct. Yes, you can. Yes. Okay, so we're out of time. I don't want to take too many other questions. Chocolates. I have to ask. Okay, question. How many keywords did we add to the language for coroutines? That's an easy one. Yes, hand over there. One. There's one.
Sorry, put your hand up again.
Put your hand up again. I showed a feature that's only available in Kotlin, which is passing extension functions to higher order functions. What do we call that feature?
Lambdas with receiver.
DSL.
Lambdas with receivers. Well done. Next time, raise your hand. Yes. And I showed a thing called cross inline, which, what does it mean?
That it must not accept
Correct.
All right, and I have a question for you now. Okay, so
I'm going to take my chocolate.
No, you can take it. It's actually the best milk chocolate I've ever tasted. I'm a dark chocolate fan myself, so I do recommend it. Pick a number between 1 and 58. This is for the free ticket to the GOTO conference.
That's really easy. 57.
57. We have a boy Lenson. Hey! I don't have a ticket on me, but I do have your email. So just assure me that it's not a fake email, and I will be in contact with you. Excellent. So I'll be in contact with you. Congratulations. I'll see you at GOTO.
Yeah, by the way, I also have one thing I have to mention. So yes, there's a GOTO Amsterdam, awesome conference, but I don't have slides. But there's even also, not a more awesome conference, but there's another conference called Kotlin Conf that takes also place in Amsterdam this year in October. And Adam at the back there, Trifork, is helping us organize it. And he said, if you don't mention it, I won't buy you dinner. So Kotlin Conference is on the 3rd to the 5th of October. Okay? It's awesome. That's it.
Excellent.
Thank you.
There's still some beers if you can't see me up the front or in the fridge.